Okay, here we go. We're on page 75 in our notebooks. We're talking about triangles. This whole chapter is about triangles. Today is about congruent triangles. So our goals for today. Hopefully by the end of the lesson you will be able to tell if a figure is congruent. This is congruent to this. Also, the biggest chunk of today is that corresponding parts. This angle matches this angle. This side matches this side. It's a matching game today. And then the last one, are you going to be able to tell that those two triangles are congruent just looking at stuff inside the triangle? It's not too bad. Here we go. So the first part, we have 3 vocab words in there. Okay, the very first one, congruent. Okay, so just think about this. In order for 2 things to be congruent, it has to be exactly the same size, exactly the same shape. Congruent means equal. Corresponding angles, corresponding sides. Let's draw ourselves 2 triangles. Try to make them congruent, because I'm going to use the blank space in congruent, in the box for congruent. So let's call this triangle ABC. Let's call this triangle DEF. Okay, that's not a very good sketch. We're just going to pretend they're congruent. Okay, I'm going to add a vocab word. Are you ready? I'm going to teach you about congruence statements. Can you sneak that in? Okay, a congruent statement always says that 2 things are equal to each other, but it names it perfectly. So I'm going to tell you the congruent statement for this picture. I'm going to say triangle ABC is congruent to triangle DEF. That's the congruent statement. It's saying what specifically is congruent. Now, I secretly love congruent statements, and I know that sounds so nerdy, but I love them because they're in order. So see how letter A is first? What other letter is first in the other triangle? That means those 2 things match. So on our picture, we should put angle A is congruent to angle D. So if you have a question that asks about corresponding angles, so this next part of our vocab list, we would just literally list it. Angle A is congruent to angle D. Okay, well next, let's go to the middle letters. B is in the middle of the congruent statement. What else is in the middle? E. So literally congruent statements go in order. So that means in our picture, angle B has to be congruent to angle E. We can list that in our corresponding angles. Angle B is congruent to angle E. Question, Colton?
So you know how congruent means equal? So why couldn't you just put equal sign instead of having squiggles?
That's a great question. You said congruent means equal. Why not just put an equal sign? You could. It's the same thing. Okay, last one. C is congruent to F, right? They're both last in our congruent statement. There we go. Angle C, congruent to angle F. We are halfway done. Ugh. You've got to name the 3 angles, but then you've got to name the 3 sides. But it's the same thing with the congruent statement. Sides, you've always got to list it with 2 letters, because they're segments. So right here, let me change the color. See how A and B are in the first and second spot? And D and E are in the first and second spot? Check it, those are congruent. So right here, we can say AB is congruent to DE. On our picture, we can add a symbol. Let's just put 1 for each. Okay, well, back to your congruent statement. I'm going to do middle and last. So middle and last, BC. Middle and last, EF. Nod your heads if that makes sense. I did middle and last. So those 2 are congruent. So we can say BC is congruent to EF. So on our picture, we can add, let's do 2 lines for that one. Okay, and then the last one, let's do first and last. AC would be congruent to DF. Back up to the picture, we can add on our symbols. 1, 2, 3. 1, 2, 3. Okay, maybe you're like, why is that so helpful with the congruent statement? Guys, sometimes in the pictures they've tilted the triangles or the polygons, and so it's hard to tell what matches what. I always just go to the congruent statement because I know that's always in order. Works out great. Okay, that's it for this section. So let's start applying these concepts. Well, for the boat. So now we're going to apply it. We're going to use it. So this very first one, it says write a congruent statement for the triangles. Okay, let's just start with this triangle. I'm going to call this one triangle ABC, but then we have to be careful to make sure we put it in order. So the first one, if we start with triangle ABC, we've got to figure out what matches A. Look on the picture. See how A has 3 markings? Which one has 3 markings on this one? P. So we've got to start with P. It matters. Okay. So B's in the middle. B has 2 markings. What other angle has 2 markings? Q. So Q has to come next. Last we would end with R. R has 1 mark. C has 1 mark. And order absolutely matters in this section. You've got to be careful. Okay, now you can use your picture if you want to. So on this first one, if I start with angle A has 3 markings. What other one has 3 markings? So we've got angle A is congruent to angle P. Because I can't help myself. I stop looking at the picture and I start looking at this one. So A is first, P is first. Now I'm going to do middle, middle. B and Q. So now I know angle B is congruent to angle Q. And then last in the congruent statement, that'd be angle C is congruent to angle R. Okay, more importantly, when naming the sides, you absolutely have to put them in order perfectly. Ugh, it's hard. So again, I like defaulting to the congruent statement because I feel like they've already put it in order for me and I don't have to worry about the picture. See how they're tilted and twisted? So guys, shout out, what matches side AB? Perfect, write it down. So AB is going to be congruent to PQ. Okay, BC, middle and last. Guys, shout out, what's congruent to BC?
QR.
So QR. Okay, and then last one, I look at first and last. So A and C, first and last, congruent to what, guys? QR. I'm curious, how many of you, I think I'll stick with the picture, I'll just look at the picture from matchy. How many of you will use the congruent statement? You think? I don't know, kind of like it. Okay, let's keep going. See this one, we don't have triangles in this picture, we have a polygon. But they give us tons and tons. Okay, first thing we need to know, right here, circle it. Okay, check they're congruent. That means all the angles, each angle has a match, each side has a match. Letter A says find the value of x. Well, right here, circle this. They give you a major clue. FG is congruent to MN. Can you shout out, what does FG stand for? Look at the picture. Totally, 12 right here. And then what does MN stand for?
5x plus 2.
Okay, what can we do with that 12 and the 5x plus 2?
They're
They're equal to each other, guys. You're good at your algebra. So just do 12 equals 5x plus 2. Does it? Yeah, probably. So we can subtract 2 from both sides. We'll get 10 equals 5x. Divide by 5. All right. X equals 2. Okay, the next one, I think they're talking about angles, yeah? So angle E is congruent to angle L. Well, here's E. Here's L. What can we do with both of those measurements? They're equal to each other. It's so great. Congruent polygons will just be equal. The angles will be equal. 111 equals 5y plus 6. Go for it. Solve it. Go for it. Solve it. You've got it. Okay, give me a thumbs up. Do you agree with me? Y equals 21? Yeah, same thing. You okay with thumbs up? Okay, let's go to the next part of this section. Look at this one. I'm hoping this makes sense. Third angles theorem actually comes up a lot. So what it's saying is if you have this angle A, you know what, let's put numbers in there and start applying it. If this one is, I don't know, 30 degrees, what does angle D have to be? Okay. And then if, trying to make this appropriate. If this one, okay, that kind of looks like 90. So let's say this one's 80. If this one's 80, what's this one? Okay, this picture is a little bit wonky, right? Okay, the top one, triangle ABC. If you know the one angle's 30 and the other one's 80, how can you find the third one? Yeah, add them subtracted from 180, right? Because every triangle, all the angles add up to 180. So it is that. What's left over? So this, okay, that picture doesn't match, right? Oh well. So if that one's 70, well, what do you think this one ought to be? So what this theorem is trying to tell you is if you have an angle and an angle that match, an angle and an angle match, the third ones have to match. Does that make sense? I think when you put in the numbers, it's like, oh yeah, they would have to, right? Because you'd be doing the same thing. You'd be adding them, setting them equal to 180. Okay, so keep that in mind. It comes up later. Third angle's there. Okay, let's do this one. Find the value of x. We've got all these symbols. Where's x? Oh no! Okay, so x is on the empty angle. Check it. So technically these two equal each other? Well, how is that something equal to a blank? You gotta do something first, Sally. Did you see it?
You find out what on the left, you add 67 before, and minus 180 in the middle.
Perfect. So use your triangle sum theorem. Add them together. All three angles should equal 180. So we can find that missing one. So I'm just going to do 180 minus 54 minus 67, calculator. So we've got 180 minus 54 minus 67. Somebody agree with me on that? Sure. All right, so that one's 59. Then this one has to be 59 too. So let's just set it up. Do a little algebra. So we've got 59 equals 4x minus 5. Okay, so add 5 to both sides. We get 64 equals 4x. Divide by 4. What is it? 16? Yeah. Don't forget it. It's so nice that all the angles add up to 180 every single time in a triangle. Okay, any questions on that one? All right, next one. Fine. Question, Ellie. What do you, can you guys answer that? Ellie's question is, what all the angles in a four-sided shape add up to be? Think of a square. 90, 90, 90, 90. What does that add up to be? There you go. Ellie, let me show you. Let me show you apply it to this section. So you've got a rectangle or a square, whatever, right? Technically, Ellie, couldn't I put this into two triangles? Do you agree with me? So a triangle adds up to be, yeah? This triangle would be, put them together. If you can't remember that, think of a square. 90 plus 90 plus 90 plus 90. Always. Great question. Okay. Okay, this is a good one because we've got to check all the angles. We've got to check all the sides, but we also have to write y. So let me teach you this one. It comes up on the worksheet. Okay, so we've got to check all three sides. Does this one have a match? Check. Side and a side. Does this one have a match? Check. What about the last one? Okay, we're done with sides. It was given to us in the picture. Okay, now we've got this angle and this angle. They're both 81. Now what? Can you see any other two angles in there that are equal? Colton, do you see some?
Angle G and angle E.
How come though?
Because
I think we need something before angle G and angle E. We can say, True, true. Guys, I tried to tell you in chapter 1, these type of angles come up in almost every single chapter. The vertical angles, do you see them? So these two have to be congruent because they're vertical. So that would be our first reason we can just say vertical angles. Okay, now it's Colton's. So now we can say that this one is congruent to this one, but why? We need a reason. Kelly, do you remember?
The third angle.
Yes. So our reason would be third angles theorem. They will be forced to be congruent. There you go. I do not mind if you put everything on the picture and then you can write your reasons just like that. I'm okay with that. Okay, you ready for the next one? Flip that page. Oh yeah, I forgot. Okay, so we still have good old reflexive, symmetric, and transitive. Oh, so here we go. For reflexive, you might think this is so silly. Reflexive, remember, that's just triangle ABC is congruent to triangle ABC. Yeah? Every single triangle is congruent to itself. symmetric, you just flip it. So they started with, if triangle ABC is congruent to triangle DF, then flip it. Triangle DEF is congruent to ABC. That's symmetric. Symmetric is the flipped one. Transitive keeps coming up. So transitive, guys, in their example, which triangle are they taking out? Yep, take out triangle DEF because they're both congruent to it. They're both congruent to it, they have to be congruent to each other. Same thing, we're just using triangles now, using the same properties. Okay, let's do our last two examples. Okay, we've got another blank problem. We've got to find x, but x is part of k. K doesn't have any symbols on it. So it looks like we've got to find angle C first, right? So let's, feel free to use your calculator now. Use the triangle sum theorem, so 180 minus 58 minus 74. Guys, will you check me? Anybody back me up on that? You agree? Okay, if that one's 48, so does angle K has to be 48. So we've got 5x minus 2 equals 48. Add 2 to both sides, 5x equals 50. Divide by 5. Guys, shout out, what'd you get for it? 10. Sweet. Me too. 10. Raise your hands, you okay with those types? Even if that one part's missing, you okay? Alright, next one, is it one? Oh, it sure is. Okay, look at the pictures. Are we good on the sides? Does every side have a match? Yeah. Okay, angles. We've got a right angle matches this right angle. This symbol matches this symbol. I would say this is a one reason. What's the reason on this one? What is it? There you go. You're done. Third angle theorem will force those last two to be